My name's Rafa. I'm from a company called Clubhouse, based in Austin, but they're based out of SF. And you had a lot of options, so thanks for coming to my talk, especially after lunch. Hopefully I'll get rid of some of the sleepies, but yeah, hopefully this is enticing enough, worth the time for you. But talk is a picture's worth 1,000, like the phrase goes. Picture's usually worth 1,000 words. In this particular case, it could be lines of codes, developers, maybe not in thousands, but magnitudes of a lot, lots of contributors to open source projects that we tend to use for the image loading libraries that we have. It could be hours of time put in, but you really only need, if you look at the core of it, you only need these 3 lines to actually download an image from the internet, which is what we're going to be focused on today. The first piece of that opens up a stream, creates an I/O connection that actually pulls it from your server or wherever your remote source is. The second one passes in that stream that we get back and puts it into the bitmap factory, which is the Android SDK's decoder for the bitmaps that come back. We get the bitmap and then we set it on our image view. So these 3 lines, for whatever reason, right, we have all of these open source libraries that require lots and lots of hours, lots of maintainers, contributors, not necessarily maintainers, to perform essentially what these 3 lines are doing. Fetch our image, decode it, display it on our view. So who here uses Picasso? Okay, so less people than I thought. Glide, is anybody using Glide? Okay, some people. Fresco, we go back. Nobody uses Fresco. I talked to somebody that used Fresco, so still a thing. And Coil, I guess who uses Coil? Okay, so a good bit of people use Coil. Okay, it's widely adopted, but why, right? I actually chatted with a person, I won't name him or what company he's at, but I thought it was interesting. He actually told me that they used all 4 within their library, right? And I was going to joke that I saw one of you raise your hand more than once, right? So maybe it could be for some other side project or maybe at your company, but a lot of these are doing a whole bunch of different things, and most of us potentially haven't taken the time to look at what's really happening when we download the image. I remember having a conversation with a manager one time, back when I had hopes and dreams of doing big things, was young and naive, kind of fresher out of school. And it's like, it'd be cool to have, an open source library that a lot of people use. But I'm never going to have any ideas for that. Like, well, it could be anything. And this is the first time I ever thought about, he told me, before these libraries existed, everybody just used to do this manually. And chatting with one person, he mentioned that somewhere in their code base, it's a pretty old code base, they have an async task somewhere that hasn't been touched in years that's downloading and handling how it is that they're downloading those images. So pretty interesting. There's a whole spectrum of things. It looks like most of the people, at least in this talk, are using Coil. But it varies a good bit. So if we look back at these 3 lines, right, we're wondering why do we need all this ceremony to download an image? One of the first things that you might point out, assuming this is in an activity, is that first piece is actually going to give us an exception on the main thread, right? Android will crash it because we're performing an I/O operation on there, and that on its own isn't that big of a deal, right? We can just put it in a suspend function, take it off with the dispatcher if we're using coroutines, or if we're still using Rx, do the observe on, schedule on, all of that we tend to do to take things off the main thread there. Then the other thing is that it's not cached at this point. So you start saying, okay, it's potentially not that hard to cache it. Well, when we leave an activity, come back to it, exit the app, come back in. If you look at the network requests that you might have if you're using one of these open source libraries, you'll see you don't make the request again. Somewhere there's a few layers of caching, either in memory or on the disk, that these libraries are actually performing for you. So you start to see how all of a sudden there's a lot of boilerplate code that's adding up that you might not want to do. You'll see the network requests get fired every single time. So it can get relatively expensive from a UX perspective, waiting for the image to load, and then on the server, anytime you can omit firing requests to your server. It's just a better developer experience for everybody. The second line, when you're decoding it, this is where a lot of the magic in the image loading piece happens. So we have our decode stream, and we're passing in whatever our input was, the image from the server, and it's not scaled. What does that mean? We have an image potentially of size, a massive image, 4800, 2400 by 2400. Could be much larger than you're using, right? In the happiest path, you might be using just an avatar that your server sends back as 250 by 250, or some defined size that you're adding to an image view that you've set as 250 by 250, no problem. But if it's a much larger image, like the ones I mentioned, 2400, anything less, and you're going to put it into a 250 by 250 or anything smaller than the actual size of the image, you're going to want to make that smaller and choose the pixels that are going to be necessary to still display it in pretty good quality, because otherwise dumping all of that into memory is going to be much more expensive than necessary, and potentially you might run into out-of-memory issues or just have a really slow process going on when you're decoding the image. Another piece is that it's not oriented. I mentioned the avatars as an example of pulling images straight from the server that likely somebody manually, just static images that exist there that are already sized. In a lot of cases, you might be passing in images where somebody took a picture of them on their phone, right? So this could have been a selfie, this could have been portrait mode, landscape mode, lots of different orientations. And whenever we take a picture of that, if we were to just pass down the raw image like it was shot up at the server, if the server didn't do anything to orient it, we're going to get a weirdly shaped or oriented image if we just chunk it back into the view as is. No other changes there. So that's an issue. And then the other one is that it's not configured. What does that mean really is that when we're decoding it, and we'll walk through all of these, but when we're decoding it, the quality of the pixels that we've chosen when we start to scale it, depending on how you choose to do it, that'll cause some performance or quality issues. So again, all of a sudden you start seeing, say you know how to do every single one of these. A lot of us, thanks to these libraries, in a good way, don't have experience or have to think about this at all. But even if you did, the boilerplate and the repetition for the code having to do this, in every single project that you see, whether a side project that you're starting from scratch, company that you're going to, it's going to start to pile up. So maybe the person that's not using the library and is using the async task, not because they're using the async task, but had something going for them in regards to understanding what it is that they need specifically for their purposes in the images that they're downloading. So hopefully through this talk, you'll actually have not a way to roll your own, but a bit more of an intuition as to when you start looking into running issues, or if there were 4 libraries, I'm sure there's more beyond that. How it is that you select one and how you might get over the hump of, well, I'm getting these issues on my image download. How do I even start looking into what any of this means? So if we had to summarize what it is that the image loading libraries are doing for us, it's a few key points. One is the proper memory management, right? So I mentioned massive image that you want to put into a small image view. You don't want to chunk the whole thing into memory to only use just a part of it. So that's something that's being taken care of for us. The disk and network efficiency. So we're caching the requests, and we're also caching potentially how it is that we're decoding the image. Wouldn't want to do that manually. The concurrency in the threading. So I chatted about making the network request, being able to do that on a separate thread, not the main thread. But also, as we're decoding these images, these kind of chug away right at your resources. So you're going to want to put that on a not an I/O thread necessarily, but a computation thread. And less used, but unless you're displaying like a perfect square avatar, how it is that you transform your image and manipulate it after you've decoded it are the goals that we're trying to get to by using, if not an image library, your specific cases with downloading these images on your own. So these are the high-level points that you're trying to accomplish whenever it is that you consider going beyond those 3 lines of code. If we had to look at it at a very, very high level, those 3 lines are these 3 functions, right? We're fetching, right? We're getting the image from someplace remote. We're decoding our image, and we're transforming, potentially, but more than likely, transforming these. And this is a talk with Coil. That's going to help guide our narrative for how it is that we think about these. But really what you should be getting from all of these is how to structure a framework for thinking about all the pieces that are happening when you download the image. So slightly specific to Coil and naming, but something that you potentially would have to think of for yourself is actually having a mapper, which is going to determine how it is that you know what you pass in to your loading function or where you're going and getting the image function, whether it be from a drawable, a URL, or a file, and then mapping that over to a way that you will know how to go and fetch that thing, whether it be on the server, locally, or from a specific file path. But before we specifically look into that, I am using Coil to, again, guide the narrative. There's a good talk about the specifics of Coil and the image loading pipeline given by somebody at Android Worldwide. So that's a better reference point for the specifics, more of the specifics of Coil. But I figured since I was using Coil to guide the narrative that we would go over the API from a very high level perspective. Most people in this room, it looked like, have used Coil, so probably familiar with it, but just to make sure that everybody here is on the baseline, we have an image view. This will also work for Compose. It's a slightly separate API, but for the purpose of this talk, doesn't really matter. There's an extension function called load, and in the load, we're going to pass where it is that we're going to fetch our image from. And again, this can be a string, file path, or resource drawable, and really you can configure it to be anything you want. And there's some stuff that you're given out of the box. But we're focused on getting an image from the web. That load function isn't doing too much, but just as a high-level overview here, that string that we passed in is actually defined here as an any because we can pass in multiple different types that are telling us where our image lives, and the loader is actually handling how it is that it executes the pipeline. Then we have our builder Lambda function that is able to take in different configuration points that allow us to customize what it is that we want out of the library. And the magic actually happens when we on-queue that image loader. This is going to return a disposable that we can handle separately in our activity or wherever it is that we need to, if needed. But the image loader on-queue actually kicks off the pipeline. In our builder, like I was highlighting before, we can pass in the specific configurations or ways to plug into Coil, the library, and that's what that would look like there. But more specific to Coil, again, I have the link to the talk for extending the image pipeline, but I only point these out because we talked about the image loader, and then the engine interceptor is where we're going to be focused on to actually see the different pieces for the fetcher decode transformation, and it leads into those tasks inside of there. And then this is the specific talk that I figured I would link to for the plugging into the image pipeline that goes more specifically into Coil. But this is where we're going to live. A little long, we're going to break it down, and probably can't even see in the back. But this is inside the engine interceptor. And the first piece that I pointed out that we were chatting about are the mappers, right? So why do we need these mappers? They're a little, like I mentioned, Coil specific, but if you were doing this on your own, or if you had some sort of motivation to not use one of these libraries, you'd probably need something along these lines to make whatever it is that you're building a little bit more flexible. Inside of our execute function, we're passing in the mapped data, right? So why do we need the mapped data? Because we can pass in a URL, we can pass in a file, we can pass in a drawable, and we can really define any type that we want. So how is it that we actually know, based on passing in a URL, a file, and a drawable, how it is that we want to download or go fetch these images? We have to define something for ourselves that we call a mapper. And you can, in theory, name this whatever you wanted, but this is what it's named internally in Coil. And what this is doing is that the type T is the type that this is executing on. So in our URL case, it's a string. And the value that it's getting is it's going to return the concrete type that we're going to use to fetch on. Right? So what is that in practice? In our URL case, right, this is going to work on a string. The URL is a string, and we're going to return a URI. Right? So the implementation for the mapper function here is actually just converting our string over to a URI type. And again, I'm using Coil to guide the narrative. There's going to be some ceremony in terms of error handling, things like that, that's happening beyond this, and kind of, hand waving over it. But obviously, if for whatever reason you had a URI that you were using that wasn't actually a URI, somehow got into this mapper, those errors would and could be handled. But in this particular case with the happy path, pass in the string, return a URI, right? So the string then gets mapped over to our URI, and then the key piece of this is going to be that the URI then actually gets created into a concrete type internally that is defined by our HTTP URI fetcher. So by passing in the URL, we're actually getting a specific fetcher whose sole job it is to actually go and get our image for us, which inside of our execute function, you can see that laid out. The HTTP, it's not called out specifically here because it can be any type, but for the specific case of our string that gets converted to a URI, then resolves to the concrete type of a URI fetcher, the fetch that we're going to call is actually going to make a remote call up to our fetcher and go get our image. So this is how we know we can pass in a resource ID or anything we want, and then separately have a defined place that knows where it is that it's going to go get the image for us. So let's look at the fetcher. For the sake of slides and not making it super noisy, I've kind of narrowed it down to a little bit more specific. So again, more error handling would be happening here. But there's two paths that this is potentially going to have to take. Right? One is, I mentioned the caching. Right? If it's in the cache, it's going to basically return that immediately, and if it's not, it's actually going to execute the request. So what's happening when we're reading this from the cache? The cache is backed by an LRU cache, right? So how it is that it's determined how long that the URL stays in there, everything like that is delegated over to OK HTTP. Actually, in this particular case, that's what Coil is doing. But we're going to return a snapshot, and that snapshot is essentially a path to our disk that actually contains the image, plus some other metadata. So we're going to attempt to read the image from the cache without loading it into memory first. Again, the snapshot is just basically pointing to where it exists in your file. And if it exists, we're going to return, this is a specific Coil return type, right? It's a source result. There's some other things in there that are less relevant to, again, thinking about this as a framework. But the source result is going to convert our snapshot to an image source, where that image source is going to contain the file path to the image. And this is actually delegated over to OKIO, which handles a lot of the buffering that's going to happen for when we're trying to get this image into memory. Say we don't hit, there's nothing to read from the disk cache, we're doing this for the first time. We're actually going to attempt to make a request. So we're going to execute the network request, and then we're going to get back a response. This response ideally is going to have our image, and then we're using OKIO to verify that there's a body. We're then going to attempt to write that to the disk cache, right? So immediately before, again, trying to do anything with this in memory, we're going to put this into a specific file path that then we're going to be able to reference. If for whatever reason we can't write to the disk cache, and this can happen for various reasons, right? You might have cache headers that are defined by the backend that say that you can't cache this. You might have made your cache read-only and you can't write to it, but there's various reasons why you might not be able to actually read this or write this into the cache. We're going to execute the network request again. In this particular case, if we get it back, we actually do the same thing with our image source, but otherwise we go ahead and return, after executing the network request again, we try to return the source result with our image source there. If the network request fails at any point, again, there's some error handling that's happening around that to just go ahead and make sure that it fails gracefully and doesn't crash for us. But when we're fetching, those key pieces, I guess, happen. Read to the cache. If it's not there, execute the request, attempt to do it again, and then after that, just deal with the result. But the happy path is that you actually have your image source in this source result that we return to then get decoded. So let's talk about decoding. There's a few things here that we're trying to attempt to satisfy with the decoding that happens in most of these libraries have some specific framework to do this. How it is that it's determining what specific configurations and everything to do depends on the library, and it would be different depending on your specific use case, but a general happy path, again, for we're just downloading a basic image from the internet, tends to follow this regular framework. There's some optimizations for the memory, right? At this point, we have our image on our disk cache, but being able to load that up at this point, it might be very big, right? So we're not going to want to load the whole thing necessarily. If we try to load the whole thing, there are some optimizations we can do with just reading specific bytes from each pixel, where we're assigning the pixels a certain level of bytes to retain, to actually do this more quickly, trading off potentially some quality of the image, or if you want the full quality, it's going to go a little slower, so some trade-offs there. That it's correctly oriented, like I mentioned before, this is where we're determining that. And the quality of the image, like I mentioned before as a part of the performance trade-off, we're trying to make sure that we do all of this with sacrificing as little of the image quality as possible. So when we're done with the fetch, right, we have our fetch result. And I mentioned before, these can be pretty heavy operations, so we want to put this on a different dispatcher. In Coil's specific case, this is the I/O dispatcher. You could pass in whatever one you want or do it wherever it is that's appropriate for your use case, but we're making sure that we do that. And then we start the decode with the result that we got in. And remember, our image source is inside of our result. So high level, we're gonna go through this. First thing that happens is we have our source, and our image source again was saved as a part of the snapshot. That's a path into where our image is on our disk. So we want to be able to buffer that out so that we're not loading all of it immediately in one shot. This is something else that's delegated to OKIO. Then this is where things start to get a little interesting. We're doing this on, you see at the top there, this bitmap factory. These are options that are set on, that you can configure on the Android SDK bitmap factory, which at the end of the day is going to determine, it's going to perform some low-level GPU magic to actually pull the image somehow. So we can add configurations into that so that when we do that, it does it in the most efficient way possible for us. But in this case, in just decode bounds, we set to true. What is in just decode bounds? I mentioned before, we don't want to read the whole image into memory potentially, right? So instead what we're going to do here is we're saying whenever we decode the image, and you'll notice that that line with the bitmap decode stream is actually the same line that we had in the original first 3 lines after we had our input stream, we called bitmapfactory.decodestream. So here it's being used, I guess, in the wild as a part of this. And we're actually going to start to buffer it and decode it. Because I set in just decode bounds, really the only thing that it's going to decode are the dimensions of the image. And that way we know how much image we have to work with. And at some point we have our target image where we're trying to put it in. So without loading the whole thing into memory, we know how big the image is, and we don't have to waste the resources required if our image was massive, or really in any case, we don't have to waste the resources required before knowing if we can even display the entire image. Immediately after doing that, this sets the options to, after we decode it in the bitmap factory, this sets the options to just the dimensions. So we didn't really decode the image fully, but we want to set the ingest decode bounds to false at this point because we already went through it once, and the next time that we decode it, we're going to want to get not the full image, but slightly more defined, an actual pixels. So we set that over to false. Next, we're going to deal with EXIF data. And just as a fun fact, well, I guess it's required to understand what this is doing. But EXIF data is, you can think of that as like metadata. Probably someone that's really into EXIF data and camera stuff might think that the semantics aren't correct there, but it's like metadata. When somebody takes a picture on most devices, there's a whole bunch of information that's stored along with that image, right? Namely, I don't know all of them, but location, the specs of the camera where it was taken, various other things. But we really only care about 2 for the purposes of decoding our image. Whether it's flipped and the rotation degrees for said image. Why does this matter? I mentioned you can take selfies, you can take landscape, slightly disoriented. Probably rarely ever are you taking like a perfectly 180 degrees horizontal landscape picture. But we're loading our image as the raw values oriented in the original way that the image was taken. So when we display it, you might get the weird situation where you took something in horizontal, right, and then you're seeing it in portrait mode, but it's still displaying it. It's trying to display in the full portrait mode when it should be long ways and other kind of weird, strange things, especially when you talk about taking selfies. So for our purposes, what we care about in the EXIF data is whether it's flipped and the rotation degrees so that we can then orient the image correctly. So having that, we then go through and set our images to not be mutable. So they're immutable images. Why? This is a bit of a side thing. I don't know. I'm pretty sure there's people here that maintain Picasso. So they might know potentially for the use case in Picasso, but I don't know if all image libraries do the bitmap pooling. But if you don't understand the concept of pooling, I think on a super high level, what it's doing, essentially on a super high level, what it's doing is that it's creating multiple objects that you can then reuse so that you don't have to create a new object every single time you need one. So it's recycling those and their performance gains that you get out of that. For the purposes of image loading, there's a new image loader library that's part of the Android SDK that doesn't do that, right? So how these image loading libraries will have to play with the new versions of Android, they're going to have to potentially alter their APIs a little bit to be able to do that. So this is an optimization that image loader, like native, I don't think it's replacing Bitmap Factory. Might be something that we have to look up, but I don't think it's replacing Bitmap Factory, but you can use it, I think, instead of, and it's not using bitmap pooling. It's creating ideally the immutable bitmaps, but also it doesn't work for versions less than Android 23. So by making the image immutable, you get potentially the same. I'm not sure exactly how it would compare one-on-one with performance, but there's no fragmented memory. You're able to pass this around and you get similar performance benefits than you would if you kept it as a mutable image and you weren't doing the pooling. So we make it immutable, and then these two, I'm gonna slightly, admittedly, hand wave over one, but because it's a little long and it's a little bit ceremonious, so it's easy to get lost in the detail of it. I'm gonna give you the high level, but We're going to scale, and then we're going to configure the image, set the config. We're going to look at set the config because it's a relatively short happening here. We're going to determine whether or not we need to eventually flip back, basically manipulate our image so that it's not flipped and it's not rotated, right? So we're orienting it correctly. So we're actually going to configure this to be software bitmaps. What are software bitmaps? Why do we need to do that? We have hardware bitmaps and software bitmaps, right? Hardware bitmaps are for an image that nothing needs to happen to it. You don't need to manipulate it. You can't draw it on the canvas. You can just go through and display it. And those bitmaps live on the GPU, right? So the GPU obviously is essentially made to handle, all these bits. It doesn't do anything else. So it's much faster, much better for performance. However, if you do need to manipulate the image, the hardware bitmaps are immutable. Yeah, immutable. Like, you can't touch those. You can't change them in any way. So you can't have them be hardware bitmaps. You have to change them over to software. And because the image is flipped and or rotated, implicitly that means that we're going to have to change it. So we can't use the hardware bitmaps. We have to convert them to software bitmaps. And then the other thing is the configuration for how it is that we're decoding the pixels. High level thing here is the allow RGB 565 is assigning 2 bytes per pixel. The bitmap config RGB 888 is assigning 4 bytes per pixel. What does that mean in practicality? Why does that matter? Decoding 2 bytes is faster than decoding 4. So there's, again, some image loss there. If you have super, super high quality images, potentially, this might not be for you. And it also has to be a JPEG, but we're optimizing for speed here, right, versus necessarily the quality of the image. And then we go ahead and set these into the bitmap factory option configs for this specific configuration. So this is the one I'm going to hand wave gloss over, but it's very interesting. I guess all of this could be interesting computer science concepts, but scaling the image. This one matters. So what's going to happen when you scale an image? We have the size, the dimensions of the image that we just got from the buffer. So with that, we want to determine how many of these do we actually need? How many of the pixels in the bitmap do we actually need to display on our device? Right, so we set this on a target, whether it be in image view or in compose, right? It's the composable. So, but we have the dimensions of the image and we have the size of the target. What's going to happen is, in Coil's specific case, it uses an algorithm that does this in powers of 2. But what's going to happen is that seemingly randomly, but there's a whole bunch of computer science algorithms that go, like graphics algorithms that go into how this is happening and different ones that exist. But what this is going to do is it's going to use an algorithm that's doing a whole bunch of math with powers of 2 specifically. That's basically going to determine what pixels it takes from the image to display inside of our image view. So seemingly to us, it's a little random. There's a whole bunch of science behind it, and there's a whole bunch of different algorithms that you could use to optimize for your specific needs. But the configure scale is performing that operation. And this is a huge gain for the memory and the performance side of things, because this is specifically how we're avoiding loading the entire massive image into the image view, but still having this, I don't know, depending on your perspective on your attention to detail, but basically in most cases, unnoticeable difference in between like your original image that really is a massive size and extremely high quality and blown up, and the image view that's loading onto your device in memory. So those are what the 2 configurations are doing. And then once we've done that, we're ready to go ahead and now fully decode the image. So again, we're passing in now our full input stream and then returning the bitmap as our result. So this is the bitmap ultimately that we're going to use to display onto the screen. And when we reverse the transformations, we called out earlier that if the picture was flipped or oriented in a different way, this is actually correcting that, which is why it's passing in those EXIF utils. And once it's done reorienting the image, we're ready to just send it back. At this point, it's a bitmap, and then converting to a drawable happens relatively easily. From an API perspective that we would use, it really is mostly to drawable under the hood, like way under the hood. It potentially might be doing something else, but this is going to give us a bitmap drawable type. So now we have our image, and there's going to be a bit more. I'll get into where this could be expanded on a whole good bit, but ultimately the transforming, usually you only have to do this once. Again, I don't want to overgeneralize, but depending on the needs of your app, right? If you have an avatar with a little rounded corner, a little squircle, right? It seems to be the hotness. This is, I guess, where you would perform that. At the end here, we're inside of that original big execute function, right? We've gone through the fetch phase. We've gone through the decoding of the image. We're going to talk about the transformation of this before we actually return our final result. And this actually isn't too complicated. And there's a whole bunch of things that Coil gives you out of the box, as well as Picasso, as well as Glide, in regards to transformation, and a whole bunch of not image libraries, but a whole bunch of open source repos that have like transformations. I didn't look it up before, but there's a really good like Wasabeef one that exists somewhere on the interwebs. Those are very good. At least they work for me. But inside of the initial API that we looked at, the transformation gets passed into our builder, and this is actually where we're getting it. Coil gives us that circle crop transformation. There's also the rounded rectangle one, but in any case, if you were to do this yourself, or if you just want to know how Coil is generally doing it, is you notice that we were calling a transform function, at the bottom of our execute that I showed earlier before returning our final result. Inside of that transform, we have to convert. What happens that Coil is doing is that it's converting our bitmap back to, or a drawable back to a bitmap in order to manipulate it again. And then when we're done with that, I think I'm missing a slide, but when we're done with that, we actually need to convert that back to a drawable. In this particular case, I mentioned that the result of our bitmap being written over to a drawable, because of the context in which we're downloading this in, it gives us back a bitmap drawable type. So doing the conversion over to a drawable and then back is relatively straightforward for us. If it weren't a bitmap drawable, there's a whole, it's a little bit outside of the scope of this, because it would imply in a lot of cases that it's not just, fetch the image from the internet and bring it back. But if you're working with potentially, SVGs, different vectors, there's a good bit of stuff that you need to actually do the conversion over to that the transform function in Coil is doing, and that's also happening in Picasso Glide. There's a lot of work that needs to be done there in order to do that. So if you don't remember all the pieces, again, this was to provide more so a framework into understanding like what it is that's happening under the hood of many of the image libraries that you use. The specifics and the semantics of each one are going to be a little different, but on a high level, that framework still exists. And you should take a look at those. They're actually really interesting. And all the maintainers, well, at least with like Picasso and Coil, and I honestly haven't looked as much into the other ones. They're really supportive, really open to answering questions, and they're well documented. So you should take a look and see how it is that it's performing each one of these. Now that you kind of have this framework in your head of, I can find the specifics of how it's fetching, how it's decoding, and all those pieces. But if you had to take away like the specific things, why it is that we need this, and you can remember only just a few things, this is what you should remember. And it's really just re-outlining our points from what it is that we're trying to get from these image loading libraries or doing these yourselves. So we're trying to get the memory management, right? Remember, big image that we're trying to pass into a much smaller image view, it's a big waste of memory, right? To load the entire image into there. the disk and network efficiencies with the caching, the concurrency and threading aspect of things, right? Being able to take things off the main thread in the correct times when we're fetching, when we're decoding it, and performing these heavy or I/O operations. And at the end, like I mentioned, less used, but still, super necessary in order to be able to display the images how you want them, the image transformation and manipulation. So that's it. Figure there'd be a plug for, I guess, Clubhouse. Continue conversation. There's a whole async thing, ask questions, things like that. It's kind of where I live on the internet these days. Also not really, but I work there, so I spend a lot of time testing it out. But yeah, if you have any questions, I'll be here after. But otherwise, appreciate you joining the talk.